So our very last piece here, because actually I didn't mention it in the 9 dot, I believe it was 3 portion of the chapter, is a pointer to a constant. And what I really wanted to do was just show you the versatility and value here in using a pointer as opposed to its reference instead. So just by way of introduction, we have the display values function here. You'll notice a void because we're not returning anything. So no fancy tricks here. And it's going to look for a constant int pointer and an int. So that's what it has to receive, a constant int and an int. We can see that here. Now inside of main, I actually have 2 arrays. We have one array of constant integers, or a constant int array, that's more correct. And we have an integer array of changeable integer values, right? So the big difference here is this is illegal to change, whereas this is not illegal to change. Now, think about a larger development than this one would be, right? So not these 34 lines of code, but on some larger project elsewhere, you are going to have a condition very, very similar to what this is going to kind of mimic, right? You're going to have an array of constant values, things that you do not want to have changed. You are going to have a list of zip codes that we accept for free shipping. You don't want that to change. You are going to have a list of zip codes for tuition reimbursement for Rock Valley College. You do not want that to change. You are going to have a huge master list of zip codes that matches to another huge master list of tax codes for when it is that you are calculating online sales tax. You damn sure do not want that one to be changed inadvertently through the course of running a program. Now, if I simply want to have a display, I can use the idea of the pointer and essentially do double duty here. Because as long as I'm not changing anything with this display values function, I can feed it either a constant value array or a regular integer value array. So we're just going to go ahead and run this. And we will see, here's my first integer with the constant values. Here's my integer array rather with constant values. Here is my second integer array with non-constant values, and both of them could be passed to this display values function despite the fact that they are not both constant integer pointer numbers. It's because we're just passing the pointer reference there. We're not doing any changes there. So we actually get to pull double duty on what kinds of values we're going to be able to take here because we're not breaking any of the rules. It is an integer, it is a pointer, it is an array, and really that's all that needs to be true in order for display values to run. So I will suggest that this has no immediate payback as far as the chapter material. It has no immediate payback as far as the end of chapter exercises. It's actually the reason I didn't include it when we were talking about 9.3 in the text material. But I thought over the course of the previous 24 hours that was a little bit unfair. So I baked this here into our code sample. So you can see we're not breaking any rules here, but because we're using the pointer, actually we're able to extend the functionality of display values, even though one of them refers to a constant integer array and the other one refers to a non-constant integer array.